In the world of business, you're constantly swimming in a sea of information. And honestly, it can feel pretty chaotic, right? Totally disconnected, overwhelming, kind of like all these scattered dots on the screen. The real trick, and what we're going to get into, is figuring out how to find a clear path through all that noise. How do you turn this mess into smart, strategic decisions? So that's the big question, isn't it? When the pressure is on and the data looks like a tangled mess, how do you actually move from feeling confused to feeling confident? How do you make the right call? Well, the answer is you've got to learn to speak the language of data. Seriously, statistics isn't just some boring math class you had to take. It's the art and science of navigating uncertainty. And this language, it's spoken in every single department. You've got accounting using it for audits, marketing using it to connect price with sales, finance using it to guide investments. Data is the map that shows everyone the way. So let's dive into that. This quest for certainty, this drive to make sense of the world through data, is our first big topic. We're going to see why getting fluent in this language isn't just a nice skill to have, it's absolutely essential for survival and growth today. But, before you can speak a language, you have to know the alphabet, right? So let's do that. We're going to break down the anatomy of data itself, get to know the basic building blocks that make up every single data set you'll ever come across. Okay, so take a look at this. Any data set, I don't care how complex it looks, is built from three simple things. First, you have your elements. Those are the things you're studying, like the companies listed here. Then you've got variables. Those are the characteristics you're curious about, like stock price or earnings per share. And an observation? That's just one full set of measurements for a single element, like that whole row for Abbott Labs. That's it. That's the basic blueprint for all data. Now, all those variables, they basically fall into two big families. On one side, you have your qualitative data. Just think of these as labels or names like NYSE or NASDAQ, simple categories. On the other side, you have quantitative data. This stuff tells you how much or how many. It's all about the numbers, like a share price. And getting this difference is absolutely crucial because it determines every single tool you can use from here on out. And we can get even more specific. Think of it like leveling up in a game, where each level gives you more power. At the very bottom, you have nominal data, just simple labels like company names. One step up is ordinal data, which has a meaningful order. A credit rating of AAA is definitely better than B. Then you get to interval data, where the gaps between the numbers are consistent, like SAT scores. And at the very top, the most powerful level is ratio data. This stuff has a true zero, which lets us say things like $50 is literally twice as much as $25. See how we're getting more and more precise? All right, so we've got our building blocks. We know the alphabet. Now what? How do we actually use them to say something meaningful? This next part is all about moving from that raw, messy data to some real insight. How do we start connecting the dots to finally see the big picture? This, my friends, is where the magic of descriptive statistics comes in. You start with just a pile of raw numbers. The first thing you do is organize it, maybe into a simple table. Then you can turn that table into a picture, like a bar chart, so you can actually see what's going on. And finally, and this is the coolest part, you can boil it all down to a single powerful number. Just like that, we found the average earnings per share is $2.49. We just turned 25 different data points into one clear insight. That's amazing. And man, choosing the right visual is everything. This is a perfect example. For our qualitative or categorical data, the stock exchange, a simple bar graph is perfect. It shows you instantly that most of the companies are on the NYSE. But for our quantitative numerical data, the share price, a histogram is way more powerful. It doesn't just show you the counts, it shows you the shape of the data. You can immediately see that big cluster of companies in the $20 to $40 price range. Data also has a relationship with time, and it's super important to get this right. Think of it like this. Cross-sectional data is like taking a photograph. It's a snapshot of a bunch of different things at one single moment in time. A time series, on the other hand, that's more like a movie. It tracks one thing over a period of time so you can spot trends, like how the average price of gas changed between 2004 and 2005. Okay, get ready, because now we're getting to what I think is the most powerful, most mind-blowing tool in all of statistics, the leap of inference. This is where things get really cool, because this is how we use a tiny little piece of information to understand something huge. Here's how it works. That big circle, that's your population. Every single thing you care about. Now, trying to measure all of them, that's called a census, is usually way too expensive, or sometimes it's just flat out impossible. So what do? We take a sample, a small, manageable little piece of the whole pie. And by studying that small sample really well, we can then make a super intelligent guess, an inference, about the entire population. Let's make this real. Imagine you're Norris Electronics. You've got a problem to solve. You need to know the average lifetime of your new light bulb filament. But here's the catch. The only way to test a bulb is to burn it out. It's a destructive test. You can't test all of your bulbs, or you'd have nothing left to sell. A full census is literally impossible. So what do? So what's the solution? They use that inference cycle we just talked about. Step 1, they know their population is all the bulbs they've ever made, but the average lifetime is a total mystery. Step 2, they take a sample. They grab 200 bulbs to test. Step 3, they burn them out, collect the data, and find that the average life for that sample is 76 hours. And now for step 4, the big leap. They infer that the average for their entire population of bulbs is also around 76 hours, give or take a little. And just like that, they've solved an impossible problem. Okay, so this brings us to a really, really important final point. With all this power, with all these tools and techniques, what is the real job of an analyst? Because I'm telling you, it's about so much more than just crunching numbers. First things first, you have to be terrified of bad data. Seriously, if you just blindly trust the numbers you're given, you're setting yourself up for disaster. Tiny little mistakes like accidentally typing 24 instead of 42, or a weird outlier because someone messed up a measurement, can totally wreck your results and lead to some dangerously bad decisions. Remember the old saying, garbage in, garbage out? And this is why you, the human, are still the most important part of the equation. Let the computers, let Excel do the heavy lifting. Let them do the math. Your real job, your real value, is to focus on the quality of that data, to ask the tough questions, and most importantly, to bring the strategic interpretation and the wisdom that a machine just can't. So look, if there is just one thing you remember from all of this, please let it be this. The single most important, most strategic step you can ever take to make sure you're making good decisions is to review all of your data for accuracy before you even dream of starting your analysis. That is the foundation for everything else. All right, so we've looked at the building blocks of data, how to turn it into something we can see, and even how to make that incredible leap of inference. You basically have a map now for navigating all that business uncertainty. So the only real question left is, where are you going to use it and what decisions will you make?